Okay, so let's talk about the absolute value of even powers of x. So for positive integers, n equals 1, 2, 3, and so on, and real number x, the absolute value of x to the power of 2 times n is always just equal to x to the 2 times n. Basically, this says that if you have the absolute value of x raised to an even power, because 2 times n is always even, if you double any number, any whole number, you get an even number. So the absolute value of x to any even power is just x to that even power. You don't need the absolute value. What do they mean by that? Well, what they're saying here is, if, for instance, you take the absolute value of negative 3 to the second power, well, negative 3 to the second power is positive 9, and the absolute value of 9 is just 9 itself. The absolute value of 9 is just 9 itself. On the other hand, if you do the absolute value of negative 3 to the third power, that's equal to the absolute value of negative 27. And when you're taking the absolute value of a negative number, you don't get the same number like we did here with the 9. The absolute value of a negative number is actually positive 27 here. So what this is saying is, in the case where the number on the inside has an even power, the absolute value doesn't matter. It's not going to change the answer. The number inside is 9 and it stays 9. On the other hand, if it's an odd power, that's not necessarily true. The absolute value of the number inside is not just going to be the same number. You have to change the sign. So the absolute value does have to do work here, while it doesn't have to do any work here. So anytime you see the absolute value and the inside of it is x to an even power, you can lose the absolute value completely. All right, so next thing, odd and even roots. For any integer n greater than or equal to 2, if the index n is even, so that means we're taking an even root, right? Then the nth root of a to the n is equal to the absolute value of a. So what does that mean? That means that if I have the third root, oh, well, 3 isn't even. We're talking about even ones first, right? 3 is an odd number, obviously. So let's do an even number. Let's say we're doing the square root, so we don't actually have to write the index. And it's the square root of negative 3 squared. Well, in this case, what this is saying is that the answer to this is the absolute value of negative 3. And the absolute value of negative 3 is positive 3. So the answer to this one would be positive 3. On the other hand, if I was doing an odd index, well, it's the cube root then of negative 3 to the third power. 3 is an odd number. Well, in this case, the answer doesn't need the absolute value. It's just negative 3 as the answer, and the absolute value isn't necessary. So as you can see, if the index is even, you use those absolute values. But if the index is odd, you don't use the absolute values, and you get different answers. All right, so we must use the absolute value sign when we take an even root of an expression with a variable in its radical. All right, or in its radicand is what this should say. With a variable not in its radical, that should say radicand. All right, so let's take a look. Here is a question 2, which is an example of what we're talking about here. So question 2, if there's a variable in the radicand and I take the square root, well, square root is an even root, so if I'm taking the square root of x to the 8th, right, that's actually going to be the square root of x to the 4th squared. Because I need it to be the square of something, so I'm thinking to myself, what can I square, what can I multiply by itself to get x to the 8th power? And my conclusion was, in order to get x to the 8th power, like if I didn't know what this was supposed to be, in order to get the 8th power here, the number I multiply by itself would be 4. The number I add to itself would be 4, or the number I multiply by 2 would be 4. So in this case, it's a 4. But based on what we just read, because this is an even root, I'm going to need absolute values. So instead of just being x to the 4th as the answer, instead of just being x to the 4th, the answer is actually going to be the absolute value of x to the 4th. But then we have to go back. Because this 4 here is even, because that 4 is even, in the very beginning I said if I take the absolute value of an even power of x, which 4 is an even number, the absolute value of even powers of x are just those even powers of x. So the answer here doesn't need the radical because x to the 4th is always positive, and the absolute value of x to the 4th is x to the 4th. So the answer for this question should be x to the 4th. And I'll just type that in here. X to the power of 4. Oops, that's a 1. 4. All right, and then the next question is very similar. Next question is very similar. I'm doing it pretty much the same way I did this one. So the next question is a 14. So once again, I'm thinking to myself, there's some power of x that I have to square to get x to the 14th power, right? And I'm thinking of the power of x, well, it's going to be half of 14. Because what's going to happen is I'm going to take x to whatever power this is, and I'm going to multiply that power by 2, and the answer has to be 14. So the answer I should get should just be whatever 14 divided by 2 is, and 14 divided by 2 is 7. 14 divided by 2 is 7. So now I have the square root of x to the 7th squared. And by definition, because 2 is an even number, because the index is 2, whenever there's no index written, we assume that it's a 2 in there, right? It's a square root. So whenever we have an even index, we need to use the absolute value. So this is the absolute value of x to the 7th. And we can't get rid of those absolute value because that thing we used to get rid of the absolute value previously said that if I have x to an even power, then the absolute value symbols are not necessary. But this is not an even power, this is x to an odd power. So you absolutely need the absolute value because we don't know if x itself is negative or positive. Therefore, we don't know what the absolute value of x is. So on this second question, number 3 actually, on number 3, we actually have to keep the absolute value. We can't just write x to the 7th. We have to write the absolute value, which is here, absolute value of x to the 7th, x to the power of 7. And if it's an odd power and you don't keep the absolute value, you will be marked incorrect. So if it's an odd power of x inside of the absolute value, you cannot get rid of the absolute value. You have to keep them. All right, let's try again. Oh, this case is completely different because in this case, the index is no longer an even number. So because we have an odd index, the index here is 3, which is an odd number. Because we have an odd index, we can actually go through and not have to worry about absolute values at all. So because we have an odd index, absolute values are completely unnecessary. And I'm doing the cube root of the power of x, that when I raise it to the 3rd power, because I want everything to cancel, this 3 radical and this 3 index, but I need it to finally equal x to the 18th. So what can I multiply by this 3 to make this x to the 18th power? Well, 18 divided by 3 is 6. So that's the number that goes there. And we don't need absolute values at all because it's an odd index. So 6 is the index, we're golden. The answer here is simply x to the 6. X to the 6. X to the power of 6. And then for this one here, once again, same kind of thing here. We have an even index again though, even index, which means with the even indices, if the index is even, I do have to use the absolute value and I simplify. Doing the same thing, I'm looking for the 4th root of some 4th power of x. So the power of x that I'm going to raise to the 4th power, Well, it has to be whatever 16 divided by 4 is, and 16 divided by 4 is 4. So x to the fourth is still x to the 16th. The fourth root and the outside fourth power will cancel, and I absolutely need absolute values here when I'm doing the absolute value of x to the fourth. But because the 4 is an even power, when I take the absolute value of x to the fourth, it's always positive. And therefore, the answer is just x to the fourth. We don't actually need the absolute value because it's an even power of x there. So I go through and I just type in here x to the fourth. And let's see. So this last one, number 6 here. All right, so number 6, once again, I'm dealing with an even power. Even power. And since I'm dealing with an even power, absolute values definitely come into play. They definitely come into play. So once again, I'm going to be looking for a fourth root, and it's going to be some fourth power of x. But the power of x that I need on the inside here, when I multiply the number here by the 4, has to give me a 12. So the number that you multiply by 4 to get 12 is 12 divided by 4. We could just divide these two numbers, right? 12 divided by 4 would be 3. And this is perfect. It's the fourth root of x cubed to the fourth power, which means the same thing as the fourth root of x to the 12th. Now the fourth root and the fourth power cancel each other out, and you're left with the absolute value. We need absolute value because this is even. Because this is even, we have to use the absolute value of x to the third. And then because 3 is not an even number, I keep the absolute value because I don't know if x to the third power is a negative number or a positive number, so I don't know what its absolute value is. So the answer here needs to use the absolute value symbol. It has to be the absolute value of x to the power of 3. And that should be it.